Hello everyone and welcome to day 4 of Labmas. Now today we're doing one of my favorite experiments of Labmas, and we're going to be learning about how air when heated up changes, and we're going to talk about how to create a vacuum, which is kind of fun. We also have a special guest today to help us with this experiment, and overall, ladies and gentlemen, we're just gonna have a great day. So sit back and let's go ahead and begin. Haha, we're back today. And you know what? The first 4 days haven't worked out for us. These kids have been able to do every experiment, but today is our day. Now, ladies and gentlemen, I know it's still Labmas, and now you're on break, and you don't want to be thinking about chores, do you? You want to think about relaxing and enjoying your family, which is a great time during Labmas as well as during our winter break. But today's experiment kind of has me thinking about chores. Today we're going to be learning a little bit about vacuums. Vacuum? Do you vacuum? Man, I don't think anybody wants to hear about vacuuming on break, do they? No, I don't think so. Yeah, not the vacuums that are super loud, that pick up dirt and grime and drive my dog totally insane. What we're doing today is we're going to talk about what a vacuum is. Now, if we're talking about a vacuum in space, we're talking about an area or a space in which there's no matter, or in which the pressure is so low that any particles in space do not affect any process being carried on. It is a condition well below normal atmospheric pressure and is measured in units of pressure called the Pascal. Now, that's the book definition. When we're talking about vacuum today, I want you just to think about a place with no air. All right? And you think about if we can create a place with no air on Earth. Well, with the help of Miss Alexis today, our lab is going to show just what a vacuum can do. All right, and welcome to day 4 of Labmas, ladies and gentlemen. We are here with the incredible Miss Alexis.
Hello!
And we're going to do an experiment today dealing with how fire uses oxygen to burn, but it can also increase the pressure that's put on the air as well as some water. So the ingredients you're going to need today, real simple: a candle, a plate, and I've already put water mixed with food coloring already in here. Now, oh my God, this is not going to work, is it? Look, he's got candles and water and plate. What is he doing? Miss Alexis, if you would, go ahead and light that candle from that candle.
Alrighty.
Excellent job. And you can set it right in the middle of the plate. Now, right now, there's plenty of oxygen in the room, isn't there?
Absolutely.
I can breathe really well. All right. So our candle is going to burn. But what would happen if we took one of these containers and put it over the candle? Well, what do you think is going to happen? What is your hypothesis? Miss Alexis, what do you think is going to happen?
I think with no oxygen, my hypothesis is the candle will burn out.
Okay, so the candle will burn out. Well, why do I have water all the way around?
Maybe something will happen with the water inside the glass. Let's see, maybe it'll go up, rise.
Okay.
Maybe it'll rise.
All right. Now, do you think I have the water here just for the safety of having water near fire?
That could be very helpful.
Okay, so there are a couple of options of why we have the water here. So I'm going to ask Miss Alexis, I did it again, to go ahead, and you can pick either container to put over the candle.
Okay, this one's calling me, so I'm going to use this one.
All right, just watch your arm. There we go, and let's see. All right. So what's happening right now, if you can see, is, we're gonna go ahead and zoom in here. The candle, she was right. It burned out, ladies and gentlemen. But what I really want you to see is look at what's happening to the water level. Can you describe what's happening there?
The water level has risen about maybe 2 inches here, and the candle is out.
Okay. Why do you think the water level is rising?
That's a great question. I feel like it has something to do with the pressure inside the container.
Okay, and what's causing that pressure?
Possibly the lack of oxygen there.
Okay. Do you think that there's something in this bottle right now that is trying to pull in oxygen?
Yeah,
But what is it pulling in instead?
it's pulling in that water. There's no oxygen in there.
All right. Now, do you think the same thing will happen with the other container? It's a lot bigger. There's a lot more oxygen, isn't there?
I yes, but I think something might happen a little different, but very similar at the same time.
Okay. Well, let's go ahead. Whoa. Let's go ahead and try it again. But this time, we're gonna use that container.
Alrighty.
All right.
I think it may take a little longer in the bigger container.
All right.
We shall see.
Well, let's see. Now, while we wait for this to work, if you notice, this container is bigger, it's heavier, and the candle is burning longer because there's more oxygen or more fuel for the fire inside this container. But, Miss Alexis, is the water level still rising?
Yes, absolutely.
All right. So what we can say, actually, it's
Oh, it's bubbling now. We have some gases going.
and actually, if you look at where it is bubbling, it's also where we don't have the water. That's there. What?
So there's oxygen getting in.
There is. Now, what do you think if I added some more water? Do you think it would still go in there?
I'm not sure if it'll keep going. Let's see.
Let's find out. Well, that might be
Still
it.
rising a little bit.
It's a lot slower now, isn't it?
Yes.
So what we can say is that the oxygen is being used up in there, but whatever's in here right now is trying to pull in oxygen. All right. So our conclusion for here is oxygen is the fuel for this fire, and it's going to do whatever it can to search out that fuel to stay alive. And sometimes the only place to get it is through the water and air pressure.
Absolutely.
All right. Well, thank you, Miss Alexis, for joining us today.
It's been fun. I'm
Thank you.
excited about Lab Miss.
And happy Lab Miss to you as well.
Yes.
Now, I don't know about you, that was a pretty cool experiment. It's definitely one of my favorites, and I definitely want to thank Miss Alexis for helping out. She did a phenomenal job. But let's explain kind of what happened here. Now, we had a lot of theories in that part of the video, but I want to tell you right now just what happened. Now, the candle, at first, when you put the container on top of it, it heats up the air, and as air heats up, it expands. Well, it's got to go somewhere, doesn't it? All right. Now, this cancels the depletion of the oxygen. This, as we know, oxygen is the fuel for the fire. It was the reason why the candle was burning at first. But after a while, what happened? Well, the candle went out because it starved. It didn't have any fuel to survive. Now, as the oxygen level was going down, the water level underneath was going up, and it was creating a vacuum, or a place where everything is sealed. All right? Now, like we said, when the oxygen was completely gone, the candle went out, and the volume of the air decreases, and the water rises. Because here's the thing, that container still had space in it, didn't it? Well, it needed something to fill that space. It needed something to fill that vacuum, something to fill that void. And ladies and gentlemen, what do we have underneath it? We had water to do the job. Wait, it's actually, did you see the water rise? Oh my goodness, buddy, we failed again. Oh no. And we had plenty of proof to prove this too, because if you notice during the video, we actually heard and saw bubbles. Well, That was the vacuum kind of sealing itself, wasn't it? That was the water level rising as the air volume dropped. All right, pretty cool, isn't it? So as far as lab mist experiments go, I have to say this is one of the best. Until tomorrow's. So stay tuned for tomorrow's video. I can't wait to work on it with you, and hopefully you're having some fun with this. So until then, I will see you tomorrow.